Hi guys, I'm Simon C. Welcome to this new Artificial Intelligence Radar. Today we talk Intel's distributed deep learning platform for Kubernetes and standalone inside-out tracking camera. And we'll talk about fighting honey fraud with machine learning. VentureBeat reports how yesterday Intel announced the open source release of NAUTA, a multi-user platform for deep learning distributed across multiple servers using Kubernetes or Docker containers. Intel claims that it created NAUTA to help developers and data scientists, which can define and schedule containerized deep learning experiments and check the status and results of those experiments to further adjust or run additional of them or prepare the trained models for deployment. Since it enables multiple users, NAUTA facilitates collaboration with team members. Indeed, results of deep learning experiments conducted with the platform can be shared between team members using TensorBoard, command line code, or a NAUTA web user interface. The platform can operate with a number of popular machine learning frameworks such as MXNet, TensorFlow, and PyTorch, and uses processing systems that can work with a cluster of Intel's Xeon CPUs to train models that will be deployed in production. Furthermore, SiliconANGLE reports that Intel also debuted a camera system for robots, drones, and augmented reality applications that uses a built-in deep learning chip to process visual information. The new RealSense tracking camera T265 has two wide-angle fisheye lenses that can each capture footage in a more than 160-degree field of view. The lenses are powered by a Movidius Myria 2 visual processing unit, specifically optimized for running deep learning algorithms. The chip powering the camera supports 12 processing cores that provide more than 100 gigaflops of performance. A gigaflop being a billion floating point operation per second. Intel specifies that the RealSense tracking camera T265 is good for applications where tracking the location of device is important, especially in locations without GPS service, such as warehouses or remote outdoor areas. The T265 is also designed for flexible implementation and can be easily added to small footprint mobile devices like lightweight robots and drones, as well as for connectivity with mobile phones or augmented reality headsets. For example, continues Intel integrating the T265 into a robot designed for agriculture allows the device to navigate fields in a precise lawn mower style pattern and intelligently adapt to avoid obstacles in its environment, including structures or people. Let's switch to a more sweet topic now. Honey is one of the world's most adulterated or mislabeled foods, and its authentication from its botanical sources is often expensive and time-consuming, conducted in laboratories by specialists who require special equipment. But a team of 2 college students and a high schooler developed a much more affordable computer vision-powered honey authentication tool trained to recognize certain grains of pollen, a unique marker of honey. To do that, the researchers collected different kinds of honey, spread them thinly across glass slides, and took images using a $130 microscope that they found was easy enough for an 11-year-old to use. So approximately 2,500 individual pieces of pollen were annotated and labeled to 3 categories: rounded, triangular and spiky. The system works in 2 parts. First, a pollen identification neural network detects and identifies the botanical origin, density and distribution of present pollen. This data is then used in the authentication network, which decides whether the honey is what it says it is. The paper focuses on a very small group of 10 samples, which were all classified correctly. The researchers say their approach could make honey inspection cheaper and faster. They describe the process in a paper that has been published to archive.org. Its name is Honey Authentication with Machine Learning Augmented Bright Field Microscopy. Okay guys, it's all for today. And see you next time with Artificial Intelligence Radar. Bye.